Hello guys, my name is Engineer Holiday. I'll be treating friction part 2, and in this class we want to look at full analysis of friction. Now let me call this one case 1. Let's have a mass M and let's have force P pulling, and let's have frictional force Fr like this. Now, let's say let M equal to mass at rest, or let me take a case 1. Let's say the body of mass M is at rest or just about to move under an applied force, parallel force P. Now in this case, I want to look at this case now where the body of mass M is at rest or just about to move or just move under an applied force. Now let me take this one now. If it's at rest, please take note of that. Your applied force P will be equal to Fr. And that is to say, the applied force which is going forward and the frictional force Fr which opposes the motion will be equal. And when they are equal, they will be equal to mu r. In this case now, we say P can also be equal to, don't forget, first of all, there is a reaction upward that is equal to weight downward. So this one now, if this one is resolving along the horizontal. So if you resolve along the horizontal, that's where you have this one. Then to have equation 2, it means that R must be equal to W. That means upward force equal to downward force. Assuming the body is at rest, which is equal to mg. So in this case, R equal to mg. So in conclusion, we can say if R equals to mg, applied force or frictional force equal to mu mg. The statement of this one. Now, in this case, we assume the frictional force is a limiting frictional force. Limiting frictional force. So if you assume that is a limiting frictional force, that means this mu will be equal to coefficient of of limiting or static friction. Limiting friction or static friction. Or static. But now look at the board. So that is to say this one now is what we call coefficient of limiting friction or static friction. Now let us look at a case where that means we assume that the body is not moving or the body is just about to move. That is what I call case 1. Now, and in that case, P will be equal to Fr. Now, if your mu is kinetic friction. If your mu is kinetic friction, that means the coefficient of friction given to you is coefficient of kinetic friction. That is what I'm saying. Let's say U is equal to coefficient of kinetic friction. Then in that case now, your applied force will be equal to mv square over 2x. Now look at the board. The kinetic or dynamic friction is has to do, what is the formula for dynamic force? Dynamic force is equal to what? Ma. Now look at the board. In equation of motion, v square equal to u square plus what? 2as. Now let's say the body start from rest. If what? The body start from rest now, from rest, it means that u will be equal to what? 0. And if u is 0, what, this one will cancel out. We have what? V square equal to 2as. Here what? A becomes what? V square over 2s. So this is a dynamic force. And the applied force will become dynamic when the body is what? Having a coefficient of what? Of kinetic friction. That means if this means coefficient of kinetic friction. Therefore, our P will now be equal to what? Ma, or it will now be equal to what? You substitute A in place of what? You substitute V square over 2s in place of A. We now have mv square over what? 2s, which is equal to what? Mu r. Now all of them are what? Equal in the case of what? Kinetic friction. This one is what? For kinetic what? That means when what? Coefficient of mu or coefficient of friction rather is kinetic. This is for what? For static. Now what about for what? For rolling. So what we have done here from here is for what? For dynamic. So what about if you now want to do for what? For rolling friction. For rolling friction now, that is to say, what I want to have now is what? P will now be equal to still what? Mu r. If you assume rolling friction now for P, that is to say that the force applied on what? Is on a rolling object. So it's on a rolling what? Object. The force applied is on a rolling object. So let's say the force is applied like this. We have a radius r. In that case now, since it's a circular object now, it's a circular object, so our P will be equal to mu r. And our P now, which is equal to what? Ma. A will now be a what? A centripetal acceleration. And P will now be centripetal force. P will now be equal to what? Centripetal force. So if P equal to centripetal force, therefore our A, which is what? V square over R, don't forget it's a centripetal force, which is what? Acting tangentially as the body is rolling. The V is what? Is being what? Is changing direction. So as the body is rolling, the V is changing direction. So but now that is your what? Tangential velocity. So if you put it here, we will have what? P will be equal to what? Ma be equal to what? Mv square over R, and will be equal to what? Mu r. Now don't forget, if from here you can even say mv square over r equal to what? Mu mg, where m can cancel out m on both sides. So we are going to have what? Mu what? G is equal to v square over r. Now look at the board here. Now this one now can go under by dividing both sides by g. If you divide both sides by g, what happens? You cancel it. What g? We are going to have what? V square over rg. So this is the formula for coefficient of friction in a circular object. Now we are done with case one. We have looked at frictional force when the body is just about to move or at rest. From a limiting friction perspective, I started with the limiting friction. Then I went further to talk about what? Looking at it from a what? A dynamic what? Friction, which is this one that we've just done. We just finished doing rather. So dynamic friction, which is this one. We have also looked at it from the aspect of what? Rolling friction. That means the body, when it's just about to move, when the circular object is about to move, there is a formula that relates frictional force and centripetal force. When the body is sliding, we can call dynamic force is kinetic friction. A dynamic friction can be called kinetic friction or can be called a what? A sliding frictional force. But in this case, it's not what? We assume that the body is just about to move. So that's what we have looked at in this case one. So please ensure you will subscribe to what? You want to go to case 2, watch our next video to enjoy case 2 of what? Of friction.